A battery charger that connects to a grid voltage of 230 volts, 50 Hz is used very often, especially for stored batteries or for charging starter batteries that have been idle for a long time. The battery charging current is adjusted according to the battery capacity. This current must be no more than 20% of the current specified in the capacity of that battery. One of the main parts of the charger is the diode rectifier. The AC voltage and current waveform and the rectified voltage and current waveform are shown in the figure. A major problem with rectified DC voltage is its large pulsation. In order to soften this pulsation, a capacitor is connected to the output of the rectifier. During the drop of the pulsating voltage towards 0 volts, the capacitor acts as a current source. In this way, the current never drops to 0, but at the moment of starting the next pulse, it is at a certain value. How much the current strength will be kept closer to the maximum value and less pulsating depends on the value of the capacitor's capacity. The higher the capacity value, the smaller the pulsation and the closer the voltage shape to the ideal shape of a straight line. The easiest way to remember the rectifier connection diagram. All the diodes in the connection in the picture are tilted, but directed towards the plus pole. On the opposite side of the plus pole is the minus pole. AC voltage is connected to the remaining two connections. When it comes to the DC power supply of lower power devices, a diode rectifier in integrated technology is used. However, if it is a higher current, then the product of the voltage on the diode and the strength of the current through the diode is quite large. This product represents the electrical power that is converted into heat on the diode. In this case, the diode must be mounted on a special cooler to release heat. In this case, cooling is facilitated if the rectifier is not made in an integrated but in a discrete technique where each diode is cooled separately. If it is a matter of very high power supply with DC electricity, when the strength of the current through the diode is very high, the problem is not only the heating of the diodes, which need to be further cooled, but also the consumption of electricity. Namely, the rectified current in each half-cycle passes through two diodes, so electrical energy is lost at the rate of 1.4 volts times the current strength. In such cases, the rectifier shown in the picture is used. It is produced by making a terminal in the middle of the secondary winding of the transformer, and connecting the diodes as shown in the picture. In this case, the total current on the DC side does not pass through two, but only through one diode, and thus the losses are halved.